Lesson 4.2.4. How can I use trig ratios? So the goal of this lesson is to use trig application problems, right? So apply everything we learned in the past couple lessons to everyday situations. You know, like climbing Yosemite. David and Emily are climbing El Capitan, a big cliff wall in the Yosemite National Park. David is on the ground holding the rope attached to a carabiner, a rope pulley that's on the wall. So here's David. There's a carabiner. It's a system used to help keep people safe. Above Emily, so carabiner is above Emily, so it's her, that's Emily right there. Above Emily as she climbs. When Emily stops to rest, David wonders how high she has climbed. So he wants to know how high is that from the ground. The rope is attached to his waist about 5 feet from the ground, so this is about 3 feet from the ground. That's 3 feet, and has let out about 48 feet of rope. So that's from here to there, it's about 48 feet. I guess technically from here to about there. When she goes up to the carabiner and then back down to the wall to Emily's harness. The rope at David's waist makes a 55-degree angle with the ground, and he's standing 20 feet from the wall. Assume that the rope is pulled tight. Approximately how long is the rope between David and the carabiner above Emily? So now remember, the rope goes from, like, if we make a triangle out of this, the rope's going to go, like, even past this. The rope is all this from there to there. And then this means pull tight. Like, this means, like, it's a straight line. So let's make a triangle out of this. So like that. Remember, this is 55 degrees. And we know for sure the bottom here is 20 feet. Now, there's some extra stuff here, like we know we're about, 3 feet from the ground. Emily is over here somewhere. I'm not going to know what's on there, because let's say, like, you kind of split it, right? Emily's, like, this far from the ground, but that's above the ground, so also rope. Like, this is all kind of confusing. But what we do know is this. That all I need is that this is a right angle, and I can figure out what this side is and what this side is because of a SOHCAHTOA. So if let me draw another triangle here. Right, I know this is 55. I know this is 20. I could use that triangle just to figure out what this side is and that side is. Right, let's say we're trying to figure out what the top part is. Well, list out your sides. This is opposite. This is hypotenuse. That's not hypotenuse, sorry. That was dumb. This is adjacent, and this is hypotenuse. If I'm looking for the top here, well, I have adjacent and I have hypotenuse. So, SOHCAHTOA. We have A and H. So, cosine. Cosine of my angle equals adjacent over hypotenuse. So I could solve this to figure out what the top line is. So if I do that, right, cross multiply, it's a two-step problem looks like. I get x cosine of 55 equals 20. Divide by cosine of 55. I get the x by itself. And x is approximately 20 divided by 50 in the calculator. So 20, let's turn it on. 20 divided by cosine of 55. And I get about let's go 34.9 degrees. 34.9 feet. So that's what the top is. So now here's the thing. So that's what the top is, right? 34.9. I gotta figure out what this whole length is to solve stuff later. Now, if I just want to see approximately how long is the rope between David and the carpenter, I figured that out. This 34.9. That part's done. Carabiner, sorry. So that was the top, right? How far is David from the carabiner? About 34.9. How high up the wall has Emily climbed? Describe your method. Well, now we can figure out how high she climbed. We know that we can figure out this whole side here by doing another triangle, or SOHCAHTOA, or by doing a squared, b squared, c squared, right? Pythagorean theorem if I want to. Either way works. Doesn't matter to me how we want to do this. Right, so first let's figure out how high the wall is in general. So we know this is 55. We have 20, 34.9. If I want to figure out what that is, there's multiple ways to go around this. I could do a squared, b squared, c squared, or I could do sine or cosine. It doesn't really matter. I can even do tan if I want. So there's lots of ways to solve. I can do sine or tan. Either way, I can figure out what that is. Let's do calculator. A squared plus y squared equals 34.9 squared. Because I don't want you to forget that that's a thing you could do. So I'm just going to use a calculator to figure that out. 34.9 squared is about 1218.01. And then 20 squared I will determine as 400. Make sure that's right. There we go. Right, let's solve for y squared. So y squared is going to equal this guy minus 400, about 818.01. And then we're going to square root it. So second square root. So I just want to remind you that Pythagorean theorem is a way you can do this if you have all sides. If you're only missing one side. 28.6. So that's how long this whole thing is. 28.6. Right, so that's all missing sides. So again, I could also done tan or sine, but I wanted to show you that we could do Pythagorean theorem. So this whole side is 28.6. But that's not how high she is, right? She's not the whole way out. How high is she? Well, we know we got out 48 feet of rope. So this plus all that is 48. So that means we got to go figure out how much this side is. Right, so if I do 48 minus 34.9, we get 13.1. So that's how much of the pulley rope is on this side. This is 13.1. Right, so remember, that's the rope. The rope goes 34.9 this way, then it goes 13.1 down. Now how high is she? Well, she's the rest. She is from here to the ground. So how do we figure that out? Well, we know this whole side is 28.6. We're going to subtract off the 13.1. That's going to get us 15.5. So she's about 15.5 feet high. So Emily is about 15.5 feet off the ground. And that's the problem.